So, coming back in a way what we were talking about at the beginning, the style of research. In this period, I mean, I think you were on a paper with three others, the general nature of the genetic code.
That's right.
That seemed to be about the sort of maximum number of people that appeared on any paper about that time.
Well, that was, I think it was, we wrote all that up because that was with Francis, myself, and we had two other people listed on that because they contributed to doing this. But I think that that was the maximum. But we had a rule, which, I mean, Francis expressed very vehemently at times. That is, nobody goes onto a paper unless they've either made a contribution to the actual work or contributed an essential idea. And the definition of an essential idea was that it was not the magnesium concentration. So that's why it's a joke.
Yes.
And I think that it was the essential thing. And we didn't have this putting on the chap who runs the lab onto every paper. That was not done. And so all the people who contributed to the thing were on the list, and the list was, and Francis was very strict about this. We had no freeloaders. Well, as you know today, there are only two important positions on a list of authors, some of which could be 100 long. There's the first author, who's probably done all the work. There's the last author, who's the head of the place and raised all the money. And there's all this region of anonymity. And I call it the caboose theory of publishing.
Sydney, I thought we might pick up on what we were talking about last night, where we were discussing the nature of modern experimental biology research, in particularly the large-scale, non-hypothesis-driven types of research. You have some rather strong feelings on that sort of thing, projects like the ENCODE project and so on.
So whereas originally, and I can remember that grants were given for what we used to call a boy and a toy. That is, you gave a grant, you had one assistant, who was the boy, and you had a toy. They gave you you got a pH meter. That was a sort of standard start-off grant. Now these had become very large as well, and groups began to grow in sizes. So, 30 was not uncommon, 60 was becoming common, and this now meant that most active scientists had left the field and had become managers. In other words, they took early retirement at about the age of 32 at that stage, because they had now had problems, which was to fuel the grants. The grants needed fueling with results. And then, of course, when the money came, they had to hire more people to get more results. So these things grew. And of course, we're now in the middle of quite a crisis in the funding of basic biology. And I think it's good to look back at the past and see, exactly how did it change. And of course, if we look at what has happened in the last 60 years, we've just been living in a period of constant revolution. That is, every decade, something happens which now enables more things to be done and better things to be done. And I think many of the things that we thought we'd never see in our lifetimes in terms of information are now realizable quite easily.